So we want to find the shortest distance between 4, 1 and this parabola. When you plug in 4 in here, you get 2. So like 1, 2, 3, 4. It's 2. But the point is at 1 here. Okay, the shortest distance, right? The shortest distance will be a perpendicular distance. So we need to pick the perfect point that will give the shortest distance. So let's call that point here AB, okay? Or let's just leave it as XY, I guess. Because we don't know where it is exactly right now. What we're trying to minimize is the distance between XY and 4, 1, okay? So we can express that as a distance. Distance is equal to, or distance squared is equal to, right? Y minus 1 squared plus x minus 4 squared by Pythagorean theorem or distance formula.
I think that's what she meant by.
We can try to do this geometrically, but let's stick with the strategy we've been talking about so far. So the first strategy is to come up with what is it that we're trying to optimize? It's distance. Do you guys all agree? Okay. So I have a distance equation, and then once again, it's in 2 variables. Okay, so what else do we know? Is there a relationship between x and y in the given question? Yes. Right? So I can replace this y with this. And then we get distance squared is equal to half x squared minus 1 squared x minus 4 squared. This is not the only way, but I'm just trying to I'm trying to be consistent with our procedure of optimization. There are other ways to solve this problem too. Okay, so let's call this distance squared our function of x, because I don't like this, like distance squared. Okay, so let's optimize distance squared, right? If we get the highest possible distance squared, then we have the highest possible distance, right? Okay, so to get the optimal value, we need to differentiate. And then we get x like this. Okay, we gotta set that equal to 0. And we get this. Very nice. Okay. And x is gonna equal to, sorry, I just did a calculation ahead in my head. X is gonna equal to 2. So this value here is 2. My picture is very not to scale, right? But it is 2 that will give you the smallest distance. So again, how do you know this smallest or the largest, right? Again, this is x cubed minus 8. So it's going to do this. At 2, it's a cubic function. It's going from negative to positive again. Going down and up. So it's a minimum, local minimum. Okay, so what is the smallest possible distance? Let's plug that back into here. Now we got to square root it. So therefore, minimum distance is, so the minimum distance is root 5. Okay, root 5 units. Okay, so that's the shortest distance, but the point on the curve, right? Point on parabola that will give the shortest distance will be 2, 2 by plugging in here.